Hey, I want to show you something. Let's take a little trip off of Earth and park our spacecraft somewhere near the moon. We're now almost 240,000 miles away from our home planet. That's almost 100 times the width of the United States. Now we've brought a special set of tools with us, a giant hammer and an enormous chisel. Place the chisel at the Earth's North Pole and strike its head with the hammer. The Earth cracks open like an eggshell and we see another planet. This is Theia, and it's hiding inside our planet like a yolk in an egg. If you want to find out how it got there, you'd need to travel back in time 4.5 billion years. This beautiful nebula is what will eventually become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Over time, this jigsaw puzzle of debris becomes denser and heavier. The temperature inside the giant is rising. Soon, it gets so high that it'll trigger a nuclear chain reaction. One more second, and bam! There's an explosion so powerful that the shockwaves travel far into deep space. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. But we're interested in that small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core while the oceans of lava are gradually cooling down. But some millions of years later, after the Sun's birth, you notice another small object. Here comes Theia. This small planet was formed at about the same time as Earth, and right now, it's following a crazy spiral trajectory at enormous speed. Scientists believe Theia was like a ball Jupiter and Venus played around with. Venus would pull Theia in one direction, and then Jupiter would pull it right back. But what makes up 99.8% of the mass of the solar system is the Sun. It's what makes Theia move into almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Theia is roughly the size of Mars, as wide as the Atlantic Ocean from New York to Portugal. At this point, the collision can't be avoided. Theia is traveling towards Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If this smaller planet would crash into Earth at a particular angle, Earth would most likely be torn apart, as well as Theia itself. The collision would cause a huge blast visible on other planets, even on a bright day. Nothing would be left but some burning dust and debris. Even if Theia only slightly grazes the Earth, it'll still knock out a sizable chunk. But the collision with Theia happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shockwave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site, which soon gets filled in with boiling lava. The remnants of Theia and the ejected fragments of Earth begin to orbit our planet. According to one theory, these fragments actually form two moons. At first, they travel together, but one day they get too close to each other and collide, forming one large space body. The other theory claims that all the loose shards get pulled in by the remnants of Theia, and that sometime after that, they form the moon, as we know it today. At this point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Theia that we have different seasons and 24 hours in a day. Now, Earth also has these things called lithospheric plates. These are enormous solid land masses that make up the crust of our planet. After the collision with Theia, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet, so Earth gains a kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over the next nearly 4 billion years, simple single-cell organisms evolve into the kinds of complex life you see today. According to scientists, a collision like we had with Theia is a very rare event. The probability that somewhere out there there's a planet like ours that has survived the same catastrophe is even rarer still. This may be the reason why we have yet to find other traces of other civilizations out there in space. Meanwhile, The remains of Theia are still here on Earth. Of course, it doesn't look like an actual entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of large continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Theia. They didn't mix with the Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise these lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Theia might be on the moon. The Apollo space missions brought back many soil samples for analysis, which led scientists to conclude that the moon is very similar to the Earth in structure. Someday in the future, people could drill deep down and take samples of the moon's crust. Then they'd analyze the blobs from Earth, and if their structure matched, it would be undeniable proof that Theia did hit Earth 4.5 billion years ago and gave us the moon. But for the time being, Theia remains an unsolved mystery. Scientists are still not sure that the planet actually existed. The whole idea does perfectly fit the model of the moon's creation, but it's also possible that this incredible collision may have never happened. Now, let's travel 41 light years away from Earth to the planet 55 Cancri e. It's about twice the size of Earth and 8 times heavier. Let's take out our giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than on Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon, and the structure changes. First, it turns into graphite, but then add just a bit more pressure, and the graphite turns to diamond. On Earth, diamonds form at depths 60 miles below sea level, where the pressure is 50,000 times greater than that on the surface. And the temperature there averages over 1,000 degrees, which is as hot as fire. Diamonds are often ejected closer to the surface in volcanic eruptions, but still, people mostly have to dig mines 1,500 feet deep to find these beautiful gems. Currently, the Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now, imagine a diamond the size of an entire planet! Now, let's fly back to our solar system. Our destination now is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% of the mass of Earth. Its surface is enclosed in an icy crust that's about 19 miles thick. Europa is completely covered in water. It's freezing here, 3 times colder than that of the North Pole and Earth. The water turns to ice almost instantly, but the ocean beneath the surface is still liquid. Europa has a gravitational relationship with Jupiter, just like the moon with the Earth. This creates tidal forces that heat Europa's core, which then melts the ice around it. The result is a huge ocean, 2 or 3 times larger than that of Earth's oceans combined. Scientists believe that water is one of the essential ingredients for life. This means that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans, though the water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria could live there. Europa is almost the same age as Earth, so there has been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They might be building big cities and dreaming of conquering space. But for now, all we can do is speculate, and maybe someday send a probe to Europa to find out if life is possible there.
Your alarm goes off and you open your eyes, groaning. Wait, why is it so dark? Is it still night? Your watch says otherwise. You come up to the window and see people running around in panic. Apparently, the sun has disappeared. Interestingly, people only realize it 8.5 minutes after it had happened. That's how much time sunlight needs to reach our planet. So Earth kept orbiting the recently vanished star, and people had no clue. And then the last rays of the sun reached us. What would happen to Earth, the Moon, and other planets of the solar system if the sun was to disappear into thin air? And would humans survive this catastrophe? Now, the sun is a giant light bulb supplying energy to the entire solar system. Not only our planet, but all the other celestial bodies in our star system are locked in elliptical orbits around the sun. In other words, the sun is the ruler of our world, keeping everything in balance. You see, every planet is constantly falling towards the sun because of the star's immense gravity. But there's also a lot of sideways force, aka centrifugal force, that moves the planets away. These forces are perfectly balanced at the moment, but everything would go downhill with the disappearance of the sun. The planets would still continue their forward motion and leave the borders of the solar system. Keep in mind that Earth revolves around the sun at a mind-boggling speed of 67,000 miles per hour. If there was no more gravitational pull from the sun, Earth would immediately shoot out of its orbit, and its speed wouldn't decrease. The same would happen with all the other planets in the solar system. They would go on and on through the dark cosmos until they found another object with powerful gravity that could capture them. It might last for hundreds of years. Now, let's see what would be going on our planet. Animals would likely be the first to feel the consequences of the sun's disappearance. They would become agitated as the darkness would come way earlier than usual. Birds would become quiet, settling down for the quote-unquote night. There wouldn't be any natural light at all, even moonlight. All because there wouldn't be any more sunlight for the moon to reflect. Without sunshine, there would be no photosynthesis, so plants and trees would stop growing. Herbivore animals would soon chew their way through the remaining vegetation, and there wouldn't be any food left for them, and us. The temperatures on Earth would slowly start falling. Our planet does have a core made of molten iron covered with a mantle of molten rock, so some heat would still be filtering through the planet's crust, keeping it warm. But it wouldn't last forever. People would start burning wood and coal to fight the cold and survive, but without food, it wouldn't help much. The seas and oceans would freeze, together with all their inhabitants. In the end, the atmosphere would collapse, leaving our planet vulnerable to the harmful radiation waves roaming through space. This would make life on the frozen planet even more difficult. Most living organisms wouldn't survive these harsh conditions. Those that live beneath the surface would probably survive, warmed up by the weak heat coming from the Earth's core. As for people, we would probably have to stay in large groups, using the energy received from nuclear fusion reactors. Or the whole scenario would get much more tragic. While hurtling away into space, Earth could collide with another planet, get hit by an asteroid, or even get pulled into a black hole. Or the planet could continue traveling for thousands of years until it found another star to orbit. Now, how about we take a look at what would be happening right after the disappearance of the sun? Uh-oh, that was very disturbing. Luckily, this is a very unlikely scenario because stars don't vanish just so. They can run out of their star fuel, that's true, but miraculous disappearances won't happen. If you've always imagined our planet as a solid piece of rock, it's time to find out the truth. In reality, Earth is squishy. Wait, I didn't mean the entire planet. I was talking about its insides. The thing is, Earth's interior isn't solid at all. Due to high temperatures and pressure down there, it has a squishy semi-solid consistency. Otherwise, such phenomena as volcanic activity, earthquakes, and plate tectonics wouldn't be possible. Another interesting consequence of having a planet with soft insides is a process called post-glacial rebound. Let's go back to the times of the last ice age. Look, huge portions of the surface of our planet are covered with glaciers. And this makes the underlying mantle, you see, deform and sink. And look what happens now. The Ice Age is coming to an end, and massive glaciers are melting and receding. And then a miracle happens. The mantle starts to slowly rebound back to its original position. And probably the coolest thing is that this process is still occurring in such regions as Greenland, Iceland, and Scandinavia. The land there keeps rebounding from the weight of the giant glaciers once covering these areas. And since we're talking about ice, you should know that Antarctica is home to the largest ice sheet on our planet. It contains a mind-boggling 7 million cubic miles of ice. And that, my friend, is 70% of Earth's freshwater and 90% of the planet's ice. Now, I've got some shocking news for you, so hear me out. Earth is flat. Heh, gotcha. Just kidding. But even though our beautiful planet isn't flat, it's not round either. You see, Earth's rotation makes the planet flatten at the poles and bulge at the equator. But all these nuances are too insignificant to be seen in Earth's pictures taken from space. That's why, to the human eye, our planet seems to be perfectly round. By the way, the distribution of mass on Earth isn't equal either. You know, with huge mountains in one region and mostly plains in another. These differences in mass cause small variations in the gravitational pull. Brace yourself for some disturbing news. The moon is drifting away from us. Yes, you've heard correctly. It happens at a rate of 1.5 inches a year. What's the reason? You might have heard that the moon pulls on Earth's oceans, which creates powerful tidal forces producing a bulge of water on the side of the planet facing the moon. But this bulge also influences Earth's natural satellite. It creates gravitational pull that makes the moon accelerate and move further away from Earth. You can notice this slow but sure drift. And still, in millions of years, it'll probably have a significant effect on Earth's rotation. Not only the moon, but also Earth's magnetic pole is trying to change its location. Unlike the geographical North Pole, which is a fixed location, the planet's magnetic north wanders. Around 30 years ago, it was believed to lie in Canada, about 990 miles south of true north. But soon, scientists realized it was actually moving at a rate of around 9 miles a year. Even more bizarre, since then it's sped up and is now moving at more than 30 miles per year. Outside of the Antarctic dry valleys, the Atacama Desert in South America is the driest place on Earth. It stretches for more than 38,000 square miles, but only gets 0.4 inches of rainfall per year. And still, despite these incredibly harsh conditions, a number of unique plants and animals manage to survive in this region. And have you seen its stunning landscapes? All those geysers, salt flats, and towering volcanoes? No wonder it's a popular travel destination. Okay, tell me, what is the largest living thing on Earth? The blue whale? Not really. Coral reefs are the largest living structures on our planet. These awesome ecosystems are made of tiny animals called coral polyps. They create calcium carbonate skeletons, which accumulate and form beautiful complex structures known as coral reefs.
Ah, Earth. The third rock from the sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creatures to breathe. The weather here is also perfect for life to exist, unlike places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles wide. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbital path, minding its own business, revolving around the sun until, BAM! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planet's orbits in the solar system have to maintain the right balance so that nothing goes haywire. Of course, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. Most of the planet will dry up and won't be suitable for growing crops. Venus is hot, really hot. Even though it's not the closest planet to the Sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the Moon, just hanging out like a fly on the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in the most dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries in general will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone needs to move towards higher ground to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more! The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The three planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join the party. So, what if Jupiter decided to turn up? Now, Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter were the size of a basketball. It also has the largest storm we can perceive. That's known as the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. Now, by the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It'll rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We'll all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow only enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, the next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. All the space debris will be blocking us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each other and break like eggs, like a big space omelet. Don't forget the moon's crashing and breaking in the mix, but we'll already be far, far away by then, hopefully. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.